we are going to tell you a few stories how Kubernetes has lost data of some users, how Kubernetes exposed things that should not be exposed, how Kubernetes corrupted data, or even how Kubernetes did not make data available to pods due to some attach and detach issues. And of course, we will focus on how we fixed it and what we learned from these failures, so you don't need to repeat the same mistakes we did. In the end, we will talk also about the open issues we have right now and how are we going to tackle them. So the first thing that users usually learn the hard way is that they should not mess up with persistent volumes and persistent volume claims. In this case, a user tried to migrate some data from a testing cluster to production cluster. They literally took YAML files of the persistent volumes and persistent volume claims, and they restored them on the new cluster. And they restored the persistent volumes first. And what happened, and that was surprising to them, that Kubernetes deleted all the data on their storage backend, and it deleted also the persistent volume object. So why it happened? This is the picture of the original testing cluster. They have a PVC bound to a PV that points to some storage in the storage backend. And then they brought the persistent volume object and restored it in the new cluster. And the persistent volume was bound. And it was bound to a persistent volume claim that did not exist at that time. They didn't restore it yet. So what Kubernetes does to bound volumes that are bound to a claim that doesn't exist, it executes the reclaim policy. So in this case, the reclaim policy was delete, and Kubernetes deleted the data. Because to the Kubernetes, it looks exactly the same, like there was a claim, there was a PV, but somebody has deleted the claim. It's exactly the same situation in API server, and Kubernetes has no way how to distinguish this failed migration or user deleting a persistent volume claim. And how did we fix it? We did not fix it at all, and we will not fix it. This is how Kubernetes works. If there is persistent volume claim, if there is persistent volume bound to a claim that doesn't exist, Kubernetes executes the reclaim policy. So what you should do as users to avoid this error, of course, we all do backups, right? You should not play with your persistent volumes. You should use some dedicated tools. For example, yesterday there was a talk about Velero from Heptio that can migrate objects between clusters. And just in case you want to play with persistent volumes, please use retain reclaim policy. So Kubernetes will not delete the data, and you can restore them later. And in this particular case, if you restore YAML files from different cluster, you should sanitize them. In this case, in the persistent volume, there is UID of the claim that it is bound to, but UIDs are assigned by Kubernetes, and they are random. So the persistent volume claim can't exist, basically. And you should also clean up some binding annotation on PV, PVC too, so Kubernetes finishes the binding, fills the UID, and everything works. And then it doesn't really matter if you restore PV first, PVC first, it will work. What we learned here, that we should educate our users. So here we are. Now you know, don't play with your PVs. And you know that our documentation is not perfect. And everybody in this room can speak English. So it's not hard to update the documentation. You don't need to write any code. You don't need to pass any API review. Everybody can contribute, and every contribution is welcome. Another case when user has lost the data, this time due to real bug in Kubernetes, was when they deleted their persistent volume claim while they had a pod running. So the user had a pod running, using some volume, using PVC, and they deleted the PVC, and while the pod was running, the data were wiped out from the volume. And the pod didn't like it, losing data underneath. Why did it happen? It's because Kubernetes API server offers no referential integrity. You can't tell it not to delete some object while it's used by different objects. So when user deleted the claim that was used by a pod, we already know what happens to persistent volumes that are bound to non-existing claims. The reclaim policy is executed, but the pod is still running. This error is not that serious because user asked for the data to be deleted. They deleted the claim. Just the order was not right. The pod was still running. How did we fix it? We introduced finalizers. Finalizers are is a Kubernetes concept. It's a field in every API object in the API server. And Kubernetes API server will not delete an object that has a finalizer. So in this case, we put a finalizer into every persistent volume claim object in the cluster using a new admission plugin. So when a user tries to delete the object, Kubernetes does not delete the object, it only marks it as terminating. And everything works, nothing is deleted. Only after the user deletes the pod, our newly introduced storage in use protection controller sees that there is a claim that is not used by any pod and it's safe to delete. So it removes the finalizer. Kubernetes API server finishes termination of the object, and the reclaim policy is executed. And now the stuff is deleted in the right order. And another case when user restored some data was quite surprising because basically they restarted Cubelet and they lost data on their volumes. What happened? The Cubelet got offline. In this case, it was due to a crash, but it doesn't really matter. It could be like, for example, Cubelet update. And at the same time, something deleted a pod on API server. And the newly restarted Cubelet basically wiped out all the data on the volume of the pod that was just deleted. Why did it happen? Kubernetes, Cubelet, uses caches to track what volumes are mounted where and for what pods, but these caches were not restored when the new Cubelet started because the API object, the pod, was not present in the API server, and Cubelet had no place how to know that the volume is still mounted. And at the same time, Cubelet has a periodic routine where it basically garbage collects the data of deleted pods. And in this case, usually the data are collected when volumes are unmounted, but in this case, the volumes were not unmounted yet. So what Cubelet did, it recursively removed all the data in the trash directory, but there was still volume mounted there, and it removed all the data from the volume. We fixed it. At first, we looked at all the places where Cubelet recursively deletes data to make sure it never happens again. And we added a special check while recursively removing data that we never cross a file system boundary. So we accidentally don't enter a mounted volume and don't remove the data there. This was just a safety check. The real fix was that we introduced reconstruction. You may have noticed that in varlib Cubelet directory, there are some crazy directories with weird names, and that's how we keep a state. And from names of these directories, Cubelet can reconstruct what volume is mounted where, and also how to clean the volume up. So when new Cubelet starts and the pod is not in the API server, at least Cubelet can restore the caches. It knows what volumes belong to which pod, and it can unmount them cleanly, and then delete all the garbage left by the pod. What we learned here was that we should run some tests for this behavior. So now we have so-called disruptive tests that run a pod, kill Kubelet, delete the pod from Kubernetes API server, start new Kubelet, and check that. Oops. Hello?
Okay.
Hello?
Okay, this one is working.
No, I'm not.
Oh, yeah, you're back.
OK, so we run the disruptive tests that test exactly this scenario. So we have our safety check, never cross file system boundary when removing data. We have the reconstruction before the bug is gone until it happened again. So how was it possible? The scenario was completely the same like before. Kubelet was down for some reason. Something deleted the pod, new Kubelet started, and wiped the data. But this time, somebody used a root disk as a persistent volume in Kubernetes. And the safety check we use to never cross file system boundary, it can't work because this root disk doesn't present a file system boundary. It's still the same root disk as we use for cache data in Kubelet. And also, the reconstruction didn't work because in this pod that was deleted, the user used so-called subpass feature, where Kubelet doesn't give the whole volume to a pod, but just a subdirectory. So once we knew that there is something wrong with subpath, we fixed it very quickly. But the lesson we learned that we should test more features combined together. So now we have whole matrix of tests that test different scenarios. And in this case, for example, we test disruptive test with local volumes with subpath. So not only Kubernetes can delete your data, it can also expose them in a very unsecured way. Last year, we have this CVE, where a malicious user could could get access to whole host file system and do anything there. Why did it happen? And it happened because a symlink that was completely innocent in the container, this symlink was evaluated on the host, and it was not that innocent anymore. Last year, me and Michelle, all from Google, we had a whole session just about this security issue, how we fixed it, including exploit. So you can look at it online. I will not cover the details here. But what we learned, of course, we should not trust user, but this is easier said than done, because what we learned also that containers can introduce security issues that were not seen before. And actually, the very same security issue was then discovered in Docker and in Kubelet copy command, kubectl copy command. And we learned also that Kubernetes has security response team, how they work, and they helped us a lot to develop a fix in some safe environment without exposing the issue and the fix prematurely.
All right, so Jan has talked about various ways Kubernetes managed to lose data. So in spite of our best efforts, in certain cases, we have noticed that Kubernetes could cause file system corruption. And I'll try to cover the cases where this could happen. And this is a story of two bugs that happened 2 years apart. So this is a stack trace from a real bug, actually. You can see the XFS metadata is corrupt. And this was reported against Kubernetes 1.10, and volume type was fiber channel, and it was reported on November 2017, so a while back. And this is another stack trace from a real bug from dmessage kernel log. You can see metadata is corrupt again, and this is Kubernetes version 1.14, so pretty recent. And it is chef RBD via CSI Rook, and it was reported in August 2019. So what happened here? The problem is basically boils down to the sometimes same volume could be temporarily mounted on more than one node at once. And typically block devices with file systems don't like it, and it could cause file system corruption. How do we fix it? And you could say that storage provider should fix it if you're probably using EBS, and EBS doesn't allow it, but in some cases, depending on what storage type you're using, it may not be possible. Another thing that Kubernetes could itself do is, Kubernetes try to be helpful, as much helpful as it can, and it has a concept of access modes. And Kubernetes could enforce the access modes associated with persistent volumes. So those of you who are not familiar with access modes, I'll just give a brief intro. What are access modes? And these are the three prominent access modes. Read-write once means a volume could be mounted as read-write on only one node. Read-write many could be mounted as read-write on many nodes. Read-only many means it could be mounted as read-only on many nodes. And this is a PVC spec. You can see access mode is specified here. And if you're using dynamic provisioning, then Kubernetes will try to bring a PV that matches your requested access mode. The thing is that Kubernetes did not enforce access mode at all until version 1.7, 1.8. So you could, it's a Wild West. You could have a volume and you could use it at two nodes at the same time and cause problems like this. So how did we fix it? We started enforcing access modes in Kubernetes, and so that you could not attach a volume that has read-write once on multiple nodes at the same time. But you may notice that this bugs that we talked in the beginning was for 1.10 and 1.14. So if this fix was made in 1.78, how come these bugs are still present? That's surprising. So we need to learn the access mode enforcement in Kubernetes, what are its limitations is. And the first thing is that it only works for volume types that are attachable. And I'll talk about what attachable means in a minute. And second thing is it does not prevent two pods from using same volume on the same node. Third thing is it's based on the cached volume state in controller manager. So all attach, detach goes through a control plane call, but that state is cached. Here is a few examples of attachable volume types: EBS, OpenStack, Cinder, GC, vSphere, disk. If you are familiar with CSI, any CSI volume that has published, unpublished controller capability is considered attachable by Kubernetes. Here are the few examples of volume types which are not attachable, like iSCSI, Ceph-RBD, Fiber Channel, and typically CSI volumes that do not have published, unpublished controller capability. These are unattachable volume types, and they typically could be attached or published to a node directly. They don't go through a control plane call. So as you can imagine that for the bugs that happen, Ceph-RBD, Fiber Channel, because the volume is not published through a control plane, they could be directly placed on a node. The access modes weren't enforced. That's why these bugs happened. So how we fixed this was we implemented a dummy attach detach interface that is basically a no-op for iSCSI, Fiber Channel, and Ceph-RBD in Kubernetes for in-tree volume types. This would basically turn non-attachable volume types into attachable, and it will ensure that the volume is made available through a control plane call to a node, not directly, and it will enforce the access mode. So that fixed the bug for the most part. But it still did not. So what are the recommendations for CSI drivers? You may have seen that the bug that happened in 1.14 was reported against Ceph-RBD CSI driver. So for CSI drivers, our recommendation is whenever possible, implement control plane-based enforcing in the volume itself so that it's more robust. And it pushes the problem back to storage providers. It may not be possible if you're running off-the-shelf storage solution. There's another alternative is like Kubernetes ships external attacher sidecar that you could use. So even though your volume does not have publish unpublished capability, the CSI calls will still go through and the access modes will be still enforced. So you can use this to get around some of the problems. And you should not disable attach detach from CSI driver object to make it work. And the last thing is that I will say is that prefer use of stateful set over deployment for workloads that use storage. That's kind of obvious, but A stateful set has stronger guarantees about pod placement. Like you cannot have 2 pods running at the same time that use the same thing. So that's another recommendation that we would make. All right, so next section that we're going to talk about is like AWS attached data issues. So who here runs AWS, Kubernetes on AWS, either via EKS or? Okay, quite a few number. So being the largest cloud provider, it is not always best tuned to run Kubernetes, I would say, and as we have been doing this for a long time, we had some starting problems and teething problems. The first issue that we noticed was that sometimes a volume will stuck in attaching and detaching state forever on Kubernetes. It was very hard to reproduce. What we found out was that AWS does not like to use the device name. AWS is unique in the sense that when you publish a volume or attach a volume to a node, you have to give a device name. Generally, all other drivers don't do that. And that device name must be free. Another thing is a race condition, like if you recently release the device and you're trying to use it again, it could cause the volume to be stuck in attaching state. So in Kubernetes, just for AWS Cloud Provider, we implemented a least recently used cache of free device names so that we don't reuse the recently released device. Another thing was that sometimes like SREs try to be helpful and they would force detach a volume from a node on AWS to, to just make the workload go, make the pod run or whatever. But what happens is that just makes problems worse, we found out. And any other volume that tries to attach on the node will also get stuck in attaching state forever. So in the end, this code is there actually in entry. We started tainting the node if the attach times out in AWS. And you have to reboot the node, delete the node object to make it work. And it kind of solves some of the pain. There's another problem that, in particular, AWS Cloud Provider we have observed is that its APIs are eventually consistent. In particular, immutable API calls like describe volume, describe instance. So some examples are like we detach a volume and we call describe volume and AWS says it's attached. We attach a volume and we say describe volume and describe volume returns is detached. So, and then sometimes in worst case, it can go back in time. Kubernetes, unfortunately, at least initially was not written to deal with this kind of problems. So how we fixed it, and it benefits other cloud providers and volume types too, is we introduce uncertain state in controller manager, where certain volumes, when we cannot be sure if it is attached, we'll mark it uncertain. Still, we are learning and trying to fix the cases, but that's how we mostly handle it. And we still love AWS. It's been pain, and we are trying to work with people in Amazon and trying to do things. So, yeah. Next, we are going to.
So this was about the issues that we fixed. We also have a couple of issues that we did not fix yet, and we are working on them. The first one that we would like to fix as soon as possible is our FS group. FS group is a feature of Kubernetes when data on volume can be owned by a random UID and GID, and also a pod runs as a different random UID or GID. And so in order to make the data on the volume available to the pod, we have a feature called FS group, when we recursively change ownership of every single file on the volume to a certain group. That works well until the volume is huge and has 10,000 millions of files, and it can take minutes, hours, days to recursively change the ownership. And the problem is that we change the ownership with every single pod restart. So yesterday we had a fruitful discussion here on KubeCon how to fix it. So currently it looks like we will introduce new API field where you could change where Cubelet would change the ownership just once and not with every pod restart. We will see how far it goes and if we can pass API review with that.
Another problem that those who are running Kubernetes on like maybe VMware or somewhere else might have seen more is like Kubernetes actually does not detach volumes from shutdown nodes. So what happens is like if you shut down a node, it does evict pods generally, not always. There's other logic built in, but it evicts the pod, but you will see that the new pods on the new nodes, replaced nodes, are not able to come up because the persistent volume is still attached to the old node, and they're not able to come up. And the reason for this is that the pods on shutdown nodes typically do not get deleted. They stay in unknown state because Cubelet is not there, so it's not able to signal whether pod is still running or not. So it's unsafe state, and Kubernetes does not detach volumes from pods in such state, and that's the reason we are not quite able to recover volumes from such nodes. Our recommendation currently is to terminate the node rather than shut down the node. If you are running in a cloud provider like AWS GCE, then if you run your cluster in autoscaling group or GKE, generally shutting down the node will cause the node to be deleted and replaced. And in that case, volumes are automatically detached from the deleted node and everything works perfect. For bare metal clusters or cloud providers that don't allow easy replacement of a node, it's a bigger problem because in that case, you cannot just do that. So our current solution is to write external controller that can monitor for shutdown nodes. If you have noticed, the shutdown nodes generally have a shutdown taint, and you could force delete the pods from those nodes. There's a cap open, and there's still consensus being built, like how do we solve this problem for good.
Another issue that we know about is emptydir. If you have a pod that uses emptydir, all these empty directories are on the same drive. So if there is a malicious pod that uses the emptydir too much, it can trash I/O for the other users. We currently don't have any solution for that. We don't even have a design. So if you are affected by this, please come to us. And we would welcome any contribution here.
This is another AWS issue. It's looking like a pattern. So this is, if you're using encrypted EBS volumes, you might notice that sometimes the volumes come with non-zero data, and that causes the Cubelet to detect random file system signature on the volume. And Cubelet is not designed to overwrite file system. So if you requested ext4 file system and encrypted volume says, I have MS-DOS partition, then Kubernetes will not delete that MS-DOS partition, and it would rather fail the mount operation, basically. This is something that we are working with Amazon and trying to fix it, but it's a pain. So yeah, in summary, I would say that fixing bugs is, I know, never-ending process. SIG storage has been involved in this effort, and we welcome more contribution from folks who are here. And we have learned from our failures, and one of the things that Jan was saying is like, we have started running a matrix of tests. So we have like subpath with local volume, GCPD plus subpath plus all the volume tests. So these days, like our test suite coverage is big. Like 40% of tests in Kubernetes is pretty much storage tests. That much testing is going on in storage. Looking at the talk, it sounds like we lost data quite a bit, but we do not lose data all the time. It's some time, and then sometimes user interaction causes it. And we're still amazed by user creativity, how users use persistent volumes. We did not expect a user to use local volume, their root disk as local volume and subpath, and that is the other code path we did not expect, and there was a bug. So we fixed it, and we try to ensure that this doesn't happen. So that's pretty much our talk. If there's any questions, then yeah.
Hi. I see you recommended using stateful set over deployment. What we have seen is in stateful set, whenever a node goes down, the problem is it doesn't do a failover. And if node went down permanently, it's fine, but if network partition and all, how do we detect those kind of scenario and we make sure that app is not affected by this failure?
Yeah. So stateful set, the question was, we recommended use stateful set over deployment, and when a node goes down, the replacement pods are not created when you're using stateful set. And the reason for that is because the pod on that is backed up by stateful set on the shutdown node or the node that is down, like crash or whatever, is still actually around. And the stateful set will not create a replacement pod until the old pod is deleted. So our current recommendation is until we solve this problem for both stateful set and deployments to force delete the pod. And you could detect, like if you're running in cloud provider, as I said, such nodes will have a shutdown taint. So you could pretty much find out, write external controller and list all the nodes that have shutdown taint, that have pods in unknown state, and you could delete them, and that will cause the replacement pods to be created. I hope that answers your question.
You mentioned storage in AWS and Google. Wondering if it's anything different in Azure, or most of this still applies the same?
Well, we run most of our tests on AWS, so that's what we tested the most, and we noticed these issues. Like, they don't happen always. They are super hard to reproduce, but they sometimes happen. But we haven't noticed these issues on GCE yet. But maybe that's because we don't run the test that much. So we don't know.
On Azure, I think we have just started testing the full E2E of Kubernetes on Azure. So it's a process that I think we'll go through. Sometimes it takes time to discover bugs on a cloud provider. So.
Meng from Foundation DB. So about your test case, suppose you have a new Kubernetes release. How long does the test take?
Can you say it again? Sorry.
So basically, how fast does your test set run? To get enough confidence, like, OK, this version of the Kubernetes doesn't have all of those bugs you mentioned.
We have several layers of tests. We run some tests for every PR. We have slow tests that run every I don't know, 1 hour. There are some scale tests. Like, you can't say how long does it take. For example, for every pull request, the tests take, I don't know, 30 minutes maybe. The slow tests, again, like 30 minutes. And I have no clue how this.
That's for one test case, end-to-end one.
No, the whole test suite.
The whole suite, OK.
Yeah, but then there are the scale tests and big tests, and I don't know how long they take.
3 hours, 2 hours.
3 hours, maybe,
yeah.
I don't know.
OK, so is this test suite like open source?
Yes, of course.
Yeah.
OK.
It's in Kubernetes.
There's a Kubernetes, some tests are in Kubernetes, some scale tests are Kubernetes/scalability testing, I guess. There's a repo where scale tests are managed. It's a different repository, but everything is
Open, and you can see the test results also. They are public.
Hey, I have a question regarding the access modes. So I have been trying different storage providers starting from 1.14. In 1.14, I could able to bind mount my volume to multiple pods on the same node. Different storage providers behave differently. On 1.16, I'm seeing a different behavior now. Rook was working for me, where I could multiple attach on the same node. Now it is broken. Looks like Kubernetes upstream code has changed in that way. There was a GitHub issue, open issue. I'm not sure whether it is closed, but there was a huge discussion going on. So basically, read-write once has to whether it should support, or do you want to add a new access mode to support multi-pod attach? Because it's just a bind mount to different paths. So what is the expectation here? So
I think correct me if I'm wrong if I got the question, like the Rook, in particularly used to have one access mode, then access mode changed?
yeah, but so other storages also have tried. So
Yeah, each storage type could define its own access mode. Like NFS has read-write many. You could mount a.
no, I'm talking about only read-write once.
Okay.
Only for this access mode, storage providers are behaving differently.
Okay, it depends. So yeah, so read-write once, it depends. Like, for example, a Rook deployment that uses CSI, and if they disable attach required in CSI driver, then, as I said, the attach detach, they will not have attach detach, and volume could be directly mounted on a node. And in that case, read-write once access mode will not be enforced.
Then what is the use of access mode?
The reason is that the access modes are not enforced almost anywhere except for attach detach. So in theory, any storage plugin can run 2 pods on the same node with read-run once. And I'm not sure we can fix it, because this is a behavior that quite some people are used to, and we would break their applications if we start enforcing the access modes like too much.
It is not enforcing, I'm asking, it is relaxing.
I mean, I don't know if you could come forward and speak. We are not able to.
Yeah, we are out of time, so thank you. Thank you.
Okay, we can talk off the island.